Dear students, today we shall learn how do the sets operate with each other, how we can treat them in an operation. Now let's get started. The three major operations that can be conducted with the set notation are union, intersection, and complement. Let us understand them one by one. If I consider union, I can understand it reminding myself of addition. In arithmetics, we have been adding things, so union is quite similar to that. Now, it can happen between two or more sets. If we have two sets and if we are to take their union, we shall note all the elements of both of the sets while not repeating any of the element that might appear in both of the sets. So this is the decorum of writing the union of a set, that we write all the elements without repetition. And the notation for union is a kind of U. We all know that Venn diagram is a useful tool to understand something graphically by using some circles and their overlaps. And if I consider the understanding of union using a Venn diagram, it would be something like this. You can see in the diagram that there are two sets that are represented with circle A and B, and their overlap is also shaded. The thing that you will note is that the shaded area, the overlapped area, is not shaded in any different color because the elements, they are written once only and they are not repeated. So this is why the overlap is not having any different color. In other words, we can say that in the union, the elements are either existing in A or they are existing in set B. And all of this shaded area is actually showing the A union B. The green area is showing A union B. A numerical example would be with the help of these two sets. One is A and the other is B, and they are having their elements. If I am to take their union, I should write on the left hand side A union B, and on the right hand side their values with union in between. As you can see, we have this set A and this is set B, and this is union, which is showing that we are going to take their union. And when we take union, as you can see, all of these, they are the elements that are written above in set A and B, and 5 and 3. These are the two elements that were there in both of them, but we have written them once only. So this is how the union takes place without any repetition. We can also consider the description form of union, and that would be X when X is an element or of A or X is an element of B. So you see that the key thing is the use of or. Either it's an element of A or it's an element of B. We can do this process and we can get the union. But there is an opposite sort of thing as well, which is known as intersection. What is that? Yes, this process basically notes down the common elements of both of the sets. Let us come to an example. There would be A and B, the same sets that we have been talking about. The symbol for intersection, however, is an inverted U. एक उल्टा U हमने बनाया. और इस प्रोसेस को जब हम देखेंगे तो हमें ऐसे लगेगा जैसे हम फैक्टराइजेशन करें, इसमें हम कॉमन लिया करते थे. इसी तरीके से यहाँ पर आपने देखा 1, 3, 5. ये वो एलिमेंट्स हैं जो कि पिछली स्लाइड्स में हमने देखा एक ही थे, दोनों में एग्जिस्ट करते थे. सो दिस इज A intersection B, 1, 3 and 5. There is another way, that is the description method of writing this, and you can see the most important thing is this AND, that A intersection B shows that A is an element of A, X is an element of A, and X is an element of B, and is used in the middle. It means that it is existing in both of them. So this is how we understand the intersection of the two sets. The diagram is self-evident. As you see, the overlap is shaded green because this is what we wanted. We wanted the intersection. And intersection is the selection of those elements that were being repeated. And you can see we are using both A and B, and is the key word. Now let's come to the final operator. It is known as the complement. It is quite similar to the subtraction that we have been doing in arithmetics. What we do is that we take a larger set that is having more elements than the set that we are considering, the complement of which we are trying to calculate. And the larger set is suitably called as universal set. And we represent it with the help of capital U. And the other set could be either A, B, or any other set. And it is necessarily smaller than the universal set. The notations, they are there, A prime or A bar or A tilde is what we use to denote the complement of a set. This example shows you a universal set which is starting from 0 and ending at 9. And A is having numbers from 1 to 5. So you see, U is greater than A. What we do is that we cancel out the similar or the same elements, and the remaining elements that are left uncancelled or they are uncommon in the universal set, they are noted as the A complement. As you can see, the uncommon factors are 0, 6, 7, 8, and 9. So we can say that we have taken the complement of set A. It can also be written in the description form. As you can see, X is when X is an element of U and X is not an element of A. So X is there in the set U, but it is not in the set A. The Venn diagram will come to help us, and you can see U is the whole rectangle. And after U is drawn, we have drawn A and B. B is not used here. We have been using it in the previous examples. However, it is there. But we are talking about A. When we exclude this A by making it white in this diagram, the remaining green area basically shows the A complement. And that will tell us that the A complement is the remaining part of the universal set after we deduct the set A from it. These were the various operations that we can do in set notation. Thank you.